Okay, so now for the new topics, we're gonna learn on numerical differentiation. Okay, so I believe that everyone is familiar with differentiation. Okay, so previously we have a function, okay, a given function, and you can just differentiate based on the function. Okay, but then we will see the difference between this numerical differentiation that you will learn in this chapter or in this course. Okay, so basically, numerical differentiation required you to find an estimation for the derivative of a function by using a given function, okay? Which is, obviously that when we talk about numerical methods, you will have a set of data. So you will actually estimate, okay? You will estimate the derivative of function based on the given data, okay? So in general, there's two situations where numerical differentiation is required. Okay, so the first one when the function is unknown. Okay, obviously that when we talk about the data, okay, so normally the function is not given. Okay, so you can only estimate the derivative based on the given data. Okay, and then the second one is the function to be differentiated is complicated, and then it's difficult to find the derivative. So the easiest way to get the derivative or to estimate the derivative is by using numerical differentiation. Okay, so technically for this chapter, okay, we're focusing on how can you use the formula or to estimate, okay, to estimate the derivative. Okay, so we will see. Okay, so in this chapter, okay, we have three types of different formula, which is forward difference, backward difference, and also centered difference. Okay, so the idea actually, okay, so the idea I just want to know or just want to introduce a bit the idea on how can you actually find this formula. Okay, the formula is given in the list of formula for your for this course. Okay, and then the idea in finding or to get this table actually, okay, so to get this table, okay, is actually come from the Taylor expansion series. Okay, I believe that you are familiar with Taylor series expansion, right? You learn about series in if I'm not mistaken, yeah, in engineering mathematics 1. Okay, but then since we for your course we are designing for you just to use it, so there's no proving at all. Okay, I just want to introduce that the list of this formula actually come from Taylor series expansion. Okay, if you guys still remember on that what should I say? Okay, maybe I can write a bit. Okay, so if you guys still remember, okay, so we have this kind of expansion. We have fx plus hf prime x plus h2 to factorial f double prime x. Okay, and then plus dot dot here. Okay, so from this one, okay, from this Taylor series expansion, okay, so Taylor series expansion here, okay, so for example for 2 point, okay, for the first derivative, okay, so we're going to consider for this part actually, for this one, okay, how can we modify it? Okay, so based on this one, for the higher derivative will be denoted as truncation error. Okay, so if we take up this one as an error, we can use as O, truncation error, okay, OH for example. Okay, so from here we will have fx plus h equal to fx plus h f prime x only. Okay, so this one is no longer considered because we take it as a truncation error. Okay, so if you rearrange this one, you will definitely get here, okay, by making f prime x as a subject, so you will definitely get like this, right? Plus h minus fx, so divided by h divided by h, so obviously there's no more h here, so you can see that this is the formula. Okay, but then for your for your what should I say, for your scope, there's no proving. Okay, we just make use all the formula given in the table. Okay, just want to introduce a bit where it actually come from. Okay, so the idea is every formula, okay, every formula in the table can be approved, can be proved. Okay, but then since we're gonna just use it, so let's skip that part. Okay, so let's see on how can, oh yeah, one more thing. Okay, so we have a first derivative, second derivative, third derivative up to fourth derivative for your uh for your what should I say, or for your scope. Okay, so you will see. Okay, I will later on during classes I will share the what should I say, the list of formula. Okay, it's not all formula in the table is given in the list of formula. Okay, so you will see why. Okay, so let's see this example and exercise. Okay, from this one. Okay, so let's see, we have, okay, so now we have, okay, they give that Faraday laws is given by this one. Okay, and then you got this data, the set of data. Okay, and then the question said that if given L is equal to 0.4, the question asks you to compute the voltage at 0.2 using 3-point centered difference formula. Okay, so take a look at this one. Okay, so this one, okay, so obviously that this one is first derivative, right? First derivative for this one. Okay, which means I prime here. Okay, so 3-point centered difference. So we will see, okay, 3-point centered difference. So we're going to make use this formula for the first derivative because the question asks for first derivative. So you're going to make use this formula. So we'll see from here. Okay, so now instead of we have what should I say, and f, so now we have I because the function given is in terms of I. Okay, so you can just use or change from f becoming I here. Okay, just make use that formula. Okay, the formula for 3-point centered difference. Okay, so you will estimate. Okay, so from here we know that h is what should I say, the start length or the difference between the first data and the following data. So this one is given. If it's not given, you can actually get it from this data. Okay, so from here you can just use or apply the formula and then you calculate it. Okay, but then the question asks you to compute the voltage, right? So the voltage now is equal to L I prime. Okay, so L is given, so don't forget to multiply with 0.2 with these values that you calculated using 3-point centered difference formula. Okay, so I would say that for this chapter, you just make use all the how can I conclude it? I mean, how can I say it? That the question is more focusing on the calculation using the formula given. Okay, but then for certain question, okay, you will see in the next exercise. Okay, you can see that not every formula, okay, as listed in the table is suitable for you to calculate or to estimate it. Okay, so we will see why. Okay, so let's move to the second example. Okay, so for this example, okay, so the question asks you to estimate the velocity and acceleration for the rocket. Okay, so now, okay, so they just give you the distance from the Earth's surface and also the time. Okay, but then how can you actually estimate the velocity? You should at least have what is the function. Okay, so but then we knows that, okay, velocity, okay, you learn about it, right? What is the equation, or I would say that the terms represent velocity and acceleration. How can you get velocity and acceleration? Okay, you as an engineering student obviously familiar with that one, right? Okay, so if we let v as the velocity, okay, since velocity is the rate of change of distance traveled, so v is equal to dy dt. So obviously that this one is first derivative, and then the question asks you, okay, to estimate the velocity, okay, when t equal to 3 seconds by using 5-point difference formula. Okay, so we take a look back at this one. Okay, because velocity now is first derivative, so we're gonna make use this formula now. Okay, so everything is in the table actually. You just have to decide which one that you should use. Okay, so you just make use the formula. Okay, substitute all the values. Okay, from here when you substitute the values of h, okay, and also t, okay, because t is asked at t equal to 3, you will get y5, y4, y2 and y1. Okay, so this value you can get it from this table. Okay, So from that, you will get the final answer. Okay, it's just that how we learn on how can use the formula, and also based on the given data. Okay, how can you apply? Okay, so the next one is for acceleration. Okay, so we know that acceleration is the rate of change of velocity. So now we have y double prime, means that now is changed to second derivative. Okay, but then still we would like to use 5-point difference formula. So we take a look back for second derivative. 5-point centered difference will be this one. Okay, you have to be able to identify, okay, which table that you want to use. Okay, so from that we'll just make use that formula. Okay, same what should I say, same procedure, same step. Okay, after you figure out which formula that you will use, okay, you can just substitute the values of t and h as given in the question. Okay, and then you will make use the data as given in the table, and then you got the final answer. Okay, as simple as that. But then this the idea on how can you get the answer, actually on how can you interpret the data given, or you can interpret the information given in the question. Okay, so let's move to example of 4.33. Okay, so now, okay, the question asks you to estimate f prime, okay, at certain point using the most two suitable point finite difference formula. Okay, so if you see for the first one is the first derivative. Okay, so you can see that this one using 2-point finite difference formula, right? So we take a look at this one, 2-point. Okay, when we talk about 2-point, so now we have two options, the first option and then the second option. Okay, and then the question asks you, okay, use the most suitable 2-point finite difference formula. Okay, so I would like you to think about it. Okay, why for x equal to 1.5 is suitable for you to use 2-point forward difference. Okay, but then for 2.0, I mean when x equal to 2.0, you have to use 2-point backward difference. Okay, I want you to think about it. Okay, so we will discuss during a live discussion regarding this one. Okay, the answer is there, but then how can you actually identify which one is the most suitable based on the formula given? Because the formula is given, data is given, but then how can you choose based on the formula? Okay, so I would like you to think about it. Okay, and I will ask during live session. Okay, and then I have include all the I also include exercise here. Okay, I will share the file answer during class. Okay, so I would like you to try it by your own. Okay, because for this one is particularly on how can you use, or how can you identify which formula that you want to use, and then you calculate it to get the final answer. Okay, so I think that's all for this video. Thank you.